So here the velocity is resolved into two components, one is along x-axis, the other one is along y-axis. V is nothing but the final velocity, U is nothing but the initial velocity, A is acceleration and S is the displacement. We can easily find out what is the maximum height or what is the maximum vertical position that an object is projected up to. We know for a projectile motion, time of ascent is equal to time of descent. Hello everyone, welcome to session 4 of chapter 4, Motion in a Plane. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. In this chapter, we are in a discussion of a body which is travelling in two dimensions, or it is a motion in a plane. So, in the study of motion in a plane, we were in the topic projectile motion. In the last session, we had studied what is projectile motion. What do we mean by projection? And we even studied few definitions or terminologies in the motion of an object, which includes time of flight. What is the meaning of time of flight? Maximum height. In the projectile motion, if a body reaches maximum position, then maximum vertical position, we will call it as maximum height. What is range? That is the maximum horizontal distance travelled by an object, we will call it as range. And we even studied about the trajectory. Trajectory is nothing but the path followed by an object which is in a projectile motion. And the path or the trajectory of a body which is in projectile motion is always a parabolic shape. We will call it as the trajectory of a projectile is always parabola. And even we have proved how we say that the trajectory of a projectile is parabola in our last session. So, in today's session, we are going to discuss about few more interesting concepts about topic motion in a plane. So, in this session, we are going to derive the expression for maximum height reached when an object is in projectile motion. What is the expression to find the maximum height of an object and time of flight, and also we are going to derive an expression for the range of a projectile. So, before deriving all these things, we must understand the representation of the projectile motion diagrammatically. So, here from origin the body is projected to the space, it is thrown into the space. So, it is having both horizontal motion as well as the vertical motion. So, here the velocity is resolved into two components, one is along x-axis, the other one is along y-axis. So, here this is the maximum height reached by the object, which means the maximum vertical distance that attained by an object, and we will call it as maximum height. And also the horizontal distance travelled by an object during the projectile motion, we will call it as range, and the time required by an object to reach the ground again after it gets projected, we will call it as time of flight. So, let us now derive the expression for all these things. Here we are considering a body which is thrown up at an angle to the horizontal with a velocity. So, you can observe here the body is thrown up to the space at an angle with the horizontal with some velocity. So, this velocity of projection, it is resolved into two components along x-axis and y-axis respectively. So, along x-axis we can say Ox, and along y-axis it is Oy. So, velocity is resolved into two components, along x-axis it is Ox, along y-axis it is Oy respectively. Now, the horizontal component in the projectile motion, the horizontal component remains constant. But what happens to the vertical component? The vertical component gets affected by the acceleration due to gravity. So, this is the very important thing which we have to understand. In the projectile motion, horizontal component does not affected by any parameter, but the vertical component affects by the gravity. So, let us now find out the expression of maximum height. So, let us consider h be the maximum height reached by the projectile in certain time. So, for vertical motion, the initial velocity, starting velocity, initial velocity be u sin theta. So, we will consider initial velocity for the vertical motion is u sin sin theta, and the final velocity is 0. Since the body initiated, the final velocity is 0 and acceleration is equal to minus g. We all know the reason for this. We have studied in the motion in a straight line chapter. The body is thrown vertically upwards, so it is minus g. For the body which is travelling upwards, the convention is negative, and the body which is falling down, and we will consider it as positive conventionally. So, we can use the equation v square is equal to u square plus 2as, which is nothing but the kinematic equation we have derived in the motion in a straight line chapter. V is nothing but the final velocity, u is nothing but the initial velocity, a is acceleration, and s is the displacement. So, from this we can write, we know now what is final velocity, it is 0. Let us substitute 0, which is equal to initial velocity is u sin theta. We have u square here, so we will get u square sin square theta. Why? Because u is nothing but initial velocity, and initial velocity is given here, which is u sin theta. So, we have u square, which means we need to square this. We will get u square sin square theta. So, in the place of u square, we are getting u square sin square theta minus 2gh. Why it is minus 2gh? Because we know acceleration, we have considered it as negative g. So, it is plus into minus is minus 2. In the place of a, we have to write g, and s is nothing but the displacement. That means we are finding the displacement at the maximum vertical position. So, s is nothing but the displacement. We need the displacement, that is height. So, s is replaced by h. Now, we are going to write the expression for height, and hence I am rearranging these terms and writing 2gh is equal to u square sin square theta. Now, from this, what is the term that I require? That is h. So, h is equal to u square sin square theta divided by 2g is the required expression for maximum height. Suppose if we know the angle of projection, we know the initial velocity, we already know the value of g. By knowing all these parameters, we can easily find out what is the maximum height or what is the maximum vertical position that an object is projected up to. So, this expression is very important even in solving numericals. So, let us now move on to time of flight. Now, we have already got the expression for maximum height. Let us now find the expression for time of flight. So, time of flight, as we all know, it is nothing but the total time required by the body to get projected and to come back again to the ground. So, this is the total time, which means time of ascent plus time of descent. So, let us now get the expression for this. Let us consider time t1 be the time taken by the projectile to reach the maximum height. If the object is thrown into space to reach maximum height, let us consider time t1, and to come back again, let us consider this time is t2. So, here let t1 be the time taken by the projectile to reach the maximum height h. As we have discussed already, for vertical motion, initial velocity is equal to u sin theta, because velocity is resolved into two components, that is along x axis as well as y axis. So, x component remains constant in a projectile motion and y component varies with gravity. So, here we have y component is u sin theta. So, for vertical motion, initial velocity is u sin theta. Now, the final velocity at the maximum height is 0, because the body is still moving at the maximum height. It is having the final velocity 0, and acceleration, since the body is thrown upwards, the acceleration conventionally it is considered as negative. So, a is equal to minus g. Now, where v is the final velocity, u is the initial velocity, a is acceleration and t is the time. As we know, the final velocity is 0 in maximum height. So, we substitute v is equal to 0 and u is nothing but initial velocity, that is given by u sin theta for the projectile motion, and a is nothing but acceleration. Conventionally, for the body which is travelling upwards, a is nothing but minus g. So, in the place of a, we are substituting minus g, and it is the time of ascent we are finding, that is given by t1. We have considered it as t1 for the object that is taken So T1 be the time taken by the projectile to reach the maximum distance. Now we are going to find the expression for time of flight, for which we require the time of ascent plus time of descent. So time of ascent is nothing but the time taken by the object projectile to reach the maximum height, that is nothing but T1. So let us retain T1 and we will write the remaining terms to the other side. So we will get u sin theta divided by g. Since g is multiplied with T1 will be equal to u sin theta divided by g. So now let us write the time of descent formula. Let us analyze what it is. So let us consider T2 be the time of descent. For the object to reach the maximum height, the time required is T1, and same projectile to come back again to the ground, the time required is T2. Let us consider. So T2 be the time of descent, but we know for a projectile motion, time of ascent is equal to time of descent. So in the discussion of projectile motion, we studied that time of ascent is equal to time of descent for a projectile motion, and hence T1 is equal to T2. So T1 is equal to T2. So let us now find out time of flight. So time of flight is nothing but the total time, which is equal to sum of the time taken by the projectile to reach maximum height and the time taken by the projectile to reach the ground. So that is T1 plus T2. So now both are same. Since T1 is equal to T2, we get T is equal to T1 plus T2 and T1 are same, and hence I am writing T1 plus T1 and we will get 2 times the T1. So what is T1? It is u sin theta divided by g, and we have time of flight is equal to 2 into T1, and hence the expression to find the time of flight is equal to 2 into u sin theta divided by g, where u sin theta divided by g is nothing but T1 value. So we get 2 u sin theta divided by g to find the time of flight, which means if we know the initial velocity, the angle of projection and acceleration due to gravity, we can find what is the time required by the projectile to reach the maximum height and again to reach the ground. That is nothing but time of flight. Now we have derived the expression for maximum height and time of flight. So let us now derive the expression for the maximum range. So what is maximum range? It is nothing but horizontal distance travelled by the projectile. So let us consider r be the range of the projectile in particular time, that is t. So this distance is covered by the projectile with a constant velocity, that is u cos theta, because we know velocity component is resolved into 2 along x axis as well as y axis. When the object is projected and this object, and here also the velocity in each point is resolved into 2 components along x axis and y axis. Along x axis the velocity is u cos theta, along y axis it is u sin theta. So here we are talking about the maximum horizontal distance, and hence the velocity is u cos theta. So what is range? Range is nothing but horizontal component of velocity into particular time, or we can say time of flight. So the horizontal component of velocity into time of flight is nothing but range. So we have the formula distance is equal to speed into time, or displacement is equal to velocity into time. We can write r is equal to horizontal component of velocity is u cos theta, time of flight is denoted by capital T. So we get r is equal to u cos theta. We know u cos theta is nothing but the velocity and t is nothing but the time of flight, and hence we are substituting u cos theta into t, and we know what is t expression we have already derived, that is 2u sin theta divided by g. So let us now multiply u cos theta into 2u sin theta divided by g. Okay, now from this you can observe we have u and u. U into u is u square, and we have cos theta and 2 sin theta. So what is 2 sin theta cos theta? So 2 sin theta cos theta is nothing but sin 2 theta. So it's a standard trigonometric relation. So sin 2 theta is given by 2 sin theta cos theta. We have 2 sin theta here, cos theta here. So multiply these two, we get 2 2 sin theta cos theta, which is nothing but sin 2 theta, and replacing cos theta and 2 sin theta with sin 2 theta. Here this u is multiplied with this u, so u into u is u square, cos theta into 2 sin theta, that is 2 sin theta cos theta, which is nothing but sin 2 theta. So I am writing sin 2 theta divided by g. So this is the expression to find the maximum horizontal distance travelled by a projectile. So we will call it as range, and range formula is u square sin 2 theta divided by g. So all three, that is maximum height, time of flight and the maximum range formulae are very important in solving numericals. So next let us move on to uniform circular motion. Uniform circular motion, name itself giving us idea what are we going to talk about. So here the motion of a particle along the circumference of a circle with uniform angular velocity is called as uniform circular motion. Consider a body which is moving along the circumference of a circle with uniform velocity. What is the meaning of uniform velocity? It means the velocity remains same at all the points. Here, if the body is moving along the circumference of the circle which is having uniform velocity, uniform angular velocity, we will call it as uniform circular motion. So when the object is travelling in a circular orbit or circular axis, the line joining the particle to the axis of rotation, the line joining the particle to the axis of rotation, we will call it as radius vector. So the next important term is the angular displacement. What is angular displacement? It is nothing but the angle described by the radius vector in a given time. So if the body is moving along circular axis, the angle described by the radius vector in a given time, we will call it as angular displacement, and the angular displacement is denoted by theta. We can observe here the particle is getting displaced with angle theta, and we will call it as angular displacement. So angular displacement is measured in terms of radians. In short form we can write it as RAD. So what is angular velocity now? Angular velocity is defined as the rate of angular displacement, that is omega is equal to theta divided by t. So angular velocity is denoted by omega. This symbol is called as omega, which is nothing but theta divided by t. What is theta? Theta is nothing but angular displacement. We know displacement divided by time is nothing but velocity. Here we are defining angular velocity. So angular velocity is equal to angular displacement divided by time. So angular displacement is nothing but theta divided by time gives us angular velocity. So since displacement is a vector quantity, angular velocity is also a vector quantity, and this angular velocity is expressed in terms of radians per second. So we know that angular displacement unit is radian and time unit is second. So when this gets transposed, we get radians per second is the unit for angular velocity. So now we are moving on to another important topic, that is the relation between angular velocity and linear velocity. We know what is linear velocity, and now we came to know what is angular velocity. Let us now write the relation between angular velocity and linear velocity. Let us consider theta be the angle subtended by the arc AB at center O. You can see here AB is nothing but the arc which is subtending an angle theta at center O. So now the angular velocity is defined as angular displacement by time, so which is given by omega is equal to theta divided by t. But what is theta? Theta is nothing but the arc divided by radians. So angular displacement is nothing but arc divided by radius. Here in this example, arc is nothing but AB and radius is nothing but r. So we can write arc is equal to AB divided by r. But what is AB? It is denoted by S in the given diagram. So it is S divided by r. But we know angular velocity is omega, which is equal to theta by t. So, theta is equal to s by r. We have omega is equal to theta by t. So, in the place of theta I have to write s by r, and t as it is I am writing. So, we get omega is equal to s divided by r into t. What is this s here? It is displacement. So, displacement divided by time gives us velocity. So, s divided by t is nothing but velocity. So, I am writing v divided by r as it is. Now, we have omega is equal to v by r, or we can write it as v is equal to multiply these two r omega, where v is nothing but the linear velocity, r is nothing but the radius, and omega is the angular velocity. This is how linear velocity and angular velocity are related with each other. So, in today's session, we had a discussion of the terms which are related to projectile motion, and even we have derived an expression to find maximum height, time of flight, and as well as the maximum range. Even we have studied what is uniform circular motion, how this angular velocity and linear velocity are related to each other. So, it is related as v is equal to r omega, and this expression is very important. It will be asked for 2 mark. So, in the upcoming session, let us discuss some more topics about motion in a plane, that is object having 2-dimensional motion. So, until then, take care all of you. Thank you.